Hi there, and welcome back to our last session where we are going to take another look at the elliptic curve digital signature algorithm protocol. More specifically, how the signature was created and how it is verified. So we are going back to our elliptic curve, and we've seen that we've had this generator point that both Apple School and Business Manager and we know about, and we saw that we could generate these points on the curve. But one point in particular was our public key that we generated by taking the generator point and adding it to itself, private key, number of times. Now this protocol is going to be based on us choosing some random point on the curve. And we know how to calculate this. All we need to do is take our generator point and add it to itself some random number of times. Now this random number is really special. It's called a nonce. A number used once. So once we've used a particular random number for a digital signature, we should never reuse it for this protocol. Now, this random point, I am going to refer to it using its x coordinate, and I'm going to label that lowercase r. Now, Apple School or Business Manager is going to need a verification function, a Boolean statement. So what I'd like it to do is to be able to reproduce that random point that we just generated. So how is it going to do this? And how does it know which point to regenerate? Well, it could regenerate this by using the generator point and using the same random value. But we are going to keep that random value private, so this method is not going to be helpful. However, we are going to take a look at the signature that we are going to create. And one of the pieces of information that we need to provide Apple School or Business Manager is which point to regenerate. So we are actually going to provide the x coordinate of that random point I would like it to generate. Now, in terms of recreating that point, we're going to have to also provide it some information. And I'm going to do that in the form of the output of our signature forge. So Apple School or Business Manager needs to recreate this point and not using the random number. So I suggest we do this in two steps. We're going to take our generator point and add it to itself u sub 1 times. I don't know what u sub 1 is at this point, but it does generate a point on the curve. And to this, we are going to add our public key, which is a point added to itself u sub 2 times, also a point on the curve. And my suggestion is we take two steps to get to our random point r. So u sub 1g plus u sub 2 public key to get to r. Now, the only thing I'm going to tell you at this point is that u sub 1 is going to rely on the information in our signature forge, which is dependent on our private key, and so is u sub 2. This actually forms the expression for our verification function, which should be able to reproduce that x coordinate of the random point that we generated. And if it checks out, we're going to get our access token. So let's put this into our diagram. So as the client, we have our header and payload. And in this protocol, we are going to hash the header and payload with our hashing function to generate a digest. We're also going to create that random point, uppercase R, by taking the generator and adding itself that random number of times. Now, like I said before, we are going to use lowercase r to represent the x coordinate of that point, and we are now going to use the variable k as our nonce. So we now have three pieces of information that I'm going to include as arguments to our signature forge function. And of course, we are always going to include the private key in our signature forge. We need to show that we are in possession of the private key. However, I'm also going to include R, K, and H, our digest. The signature forge is going to do its job and produce this value S. Remember, I told you that our signature is also going to need to include the x coordinate of the point that we randomly generated. We're going to add the signature to our Passport application and send our JSON web token over the wire to Apple School Business Manager Passport Office. It will then go ahead and inspect the contents of our message, the header and the payload, and it will go ahead and rehash the header and the payload. because if someone tried to change anything in the header of the payload, this would result in a different digest, and thus our verification function, as you'll see in a moment, wouldn't work. Now, the next thing we're going to do is grab that public key from the information from the header. And then we're going to take a look at the contents of our signature. We have the x coordinate of the random point that we want Apple Scholar Business Manager to recreate, and the output of our signature forge function, S. Both of these are going to be arguments to our verification function. In fact, we are going to be using the generator point, the S value, R, the public key, and our digest to serve as arguments to our verification function so that it can reproduce that value of R. So it goes ahead and it will compute some R prime value, and if it matches the one we sent over in the signature, then this Boolean statement is true and we will be awarded our access token, and now we have the possibility to access Apple Scholar Business Manager's Resources API. Now, before I finish off, I want to answer two questions. How do we generate this value of S from the signature forge? And how do we actually calculate this x coordinate of the random point over in Apple School Business Manager, or R prime? We're going to get started with how to generate this value of S, so the output of the signature forge. Now, we can see here that the signature forge is going to produce a value of S. That's our first goal. And then the verification function is going to generate the x coordinate of the random number that we expect Apple Scholar Business Manager to be able to recreate. Now, we know that we generate this random point over in the client using the generator added to itself k number of times. Apple Scholar Business Manager doesn't have access to k, so we came up with an alternative expression to arrive at this x coordinate. And what we did is we took the generator point and added to itself u sub 1 times, and then we took the public key and added to itself u sub 2 times. This is actually a really creative step. Now I'm going to start thinking in terms of the client and how we are able to generate that value of R without knowing the value of K. Well, we know that R is the same thing as u sub 1g plus u sub 2, but I'm not going to use public key here. I'm going to replace it with the definition, which is our generator point added to itself private key number of times. And notice that those two are associated. I'm then going to change the form of the expression so that u sub 2 and the private key are associated. And remember that math from high school that you said you were never going to use again? Well, here is your chance. If you notice that both of these terms have this common value of g, that we're going to use the distributive law to factor to the right. And if you look closely now, we actually have rewritten R in the form kg. So as the client, we can actually calculate the value of k using u sub 1 and u sub 2. And this is important because that's how Apple Scholar Business Manager is going to need to calculate its x coordinate of this random point. So what is u sub 1 and u sub 2? Well, I'm going to give it a value based on the information that we have. Now we've already used up the private key and our random value k. So what's left? Well, we have h and we have r. Notice that Apple Scholar Business Manager also has a digest, h prime and r. So I'm going to let u sub 2 be r and u sub 1 be h. And I know some of you are thinking, wait, could you have used h for u sub 2? Sure, u sub 1 would be r and the math would just change a little bit, but it would work. But I really want my private key to be protected, and my private key is about my identity. So I think it's better that it is related closely with that random generated value, which is also sort of part of our identity. And we're going to let the digest be the message all on its own. Unfortunately, this is no longer an equation. So we are going to make it one by introducing this proportionality constant, S. And this equation turns out to be very, very useful. In fact, you can see that we are just one step away from finding out how we calculate the value of our signature forge function. We are going to multiply both sides by the inverse of k to get the value of s. And there we've done it. We now have an expression that can calculate the value of s, the output of our signature forge function, which serves part of our signature. All right, but what about over in Apple School or Business Manager? They still need to be able to create that point that we randomly generated, that x coordinate, r prime. And it's going to need u sub 1 and u sub 2 to do that. Well, now we can go ahead and answer how to generate this x coordinate of the point we randomly generated over in Apple School Business Manager. Now I want you to focus over in the client. We have this expression for k, u sub 1 plus u sub 2 private key. And remember I told you we had that important equation where we had sk is equal to h plus r private key. I'm now going to come up with an alternative expression for k from sk. So k I can get by multiplying both sides by the inverse of s. So k is going to be s inverse r digest plus r private key. Now this isn't very helpful at this point. However, again, that high school math that you would never use, I'm going to use the distributive log n and distribute s inverse to both of those terms. So what I end up with is s inverse r digest plus s inverse r private key. And if you look closely now, I have two expressions for k. In fact, I'm going to highlight this private key for you. Notice that I have u sub 1 in the form s inverse h, and u sub 2 is going to be represented as s inverse r. And looking at Apple School or Business Manager, I now have values for u sub 1 and u sub 2. In fact, I can write the x coordinate of that randomly generated point that it's trying to recreate by using u sub 1 generator point plus u sub 2 public key. Well, what is u sub 1? Well, that is just s inverse and our digest that we calculated. And note, if someone tried to change anything in our payload or header, we would have the incorrect digest here and thus generating the wrong x value. And of course, u sub 2, we have s inverse and the value of r. So we now have an expression that Apple School or Business Manager that is using to create the random x coordinate that we generated. Let's go ahead and take a look here. We now have an expression to calculate the output of our signature forge function, which is s, and we now have an expression to generate the x coordinate of the randomly generated point that we generated, but in a way that Apple School or Business Manager can recreate it based on the information that we give it. So I hope that we've answered these four essential questions now. We should know what a private and public key are, and I hope that you have some sense of how the signature was created and how it was verified. And I really hope that you're able to answer this question, how to get an access token. My name is Mark, and thank you for watching.